Welcome to Brain Vision.
So we want the spring constant and the total energy of this system. So we have a mass of 240 grams. We can convert and say 0.24 kilograms. We have a frequency of 2.5 hertz. And we have an amplitude of 4.5 centimeters, and we can convert to meters and say 0.045 meters. So for part A, trying to find the spring constant, we know that the frequency is going to be 1 over 2 pi times the square root of the spring constant divided by the mass. So we can simply solve for the spring constant and say that K is going to be equal to 4 pi squared times F squared times M. And we can say this is going to be 4 pi squared times the frequency, so 2.5 squared, times the mass, so 0.24, and we have a spring constant equaling 59.22 newtons per meter. Now, to find the total energy, we can do it here, part B, E total. This is simply going to be equal to the potential energy of the spring when it's fully stretched or fully compressed. So we can simply say half times Ka squared. And so we can say E total equals 1/2 times the spring constant, which we just found, 59.22, times the amplitude of 0.045 squared. And we can say that the total energy of the system is going to be equal to approximately 0.060 joules. So this is your answer for part B, and this is your spring constant for part A. That is the end of the solution. Thank you for watching.